I'm Justin Broughton. I'm here with Cal Markert, and we've got a couple other Googlers here to help if we got questions about things. Yeah, we're with Google. We're on different teams, but we've all got kind of the same goal here of helping people be successful using Earth Engine. And today we'd like to talk about Earth Engine's two primary interfaces, the JavaScript Code Editor and the Python API. And we'd like to describe them and point out some of the differences, do a little bit of summary of the pros and cons, give you the kind of information you might need to help you decide which interface to use for a particular task. And if you're an ardent supporter and user of a particular interface, we hope that we can entice you maybe to try a different interface depending on your task and need.
I just want to say before we get started, so the other Googlers, can you just raise your hand so everyone in the crowd knows who you are and they can help out. We're not going to do too much hands-on. We're going to do a live demo. We'll walk through like Code Editor and Colab using the different APIs. You'll have those demos, but we're not going to really be doing hands-on. But if you have any questions, feel free to grab the attention of someone else that's TAing in the room.
Yeah, for the people in the audience, who's using Earth Engine currently? Raise your hands. So it looks like
it's great to see.
Pretty much everybody. How about Code Editor only, exclusively Code Editor? All right, exclusively Python. What about a mix? A little bit of both? All right. Yeah, so just the 30,000-foot view here. We're talking about these two interfaces. It's not a competition, though, so we just want to make that clear. We'll talk about the Earth Engine language, the client libraries, the development environments, and then we'll do some comparisons between Python and the Code Editor, and then we'll do a live demo of the two, go quick pros and cons summary, and then we'll just kind of have a real talk, candid, discussion about how we've been using these things. Yeah, so not a competition. I think that often, we have this JavaScript code editor and we have the Python API, and it often seems like they're kind of pitted against each other, and maybe people using R or Python, there's one better than the other, and maybe that's true for certain types of things, but we're not here to have this be a competition. And we also don't want people to stress out about having to choose one or the other, make this decision when you're learning Earth Engine. That it has to be a hard choice, that it's really a partnership. It might look like they're arm wrestling, but I really think it's like a strong handshake, that they're better together and they complement each other. And so let's talk about the Earth Engine language, and I like to think of it as the sixth love language. I showed this slide to my wife, and she rolled her eyes. Yeah, so we have, we talk about the JavaScript and the Python APIs, but 90% of what you're going to write in code is this sort of Earth Engine language, or this EE script, we could maybe say, and it's basically nouns and verbs. These nouns are these Earth Engine classes, these objects, these data types, like an image or an image collection or a feature, and then the things that you can do with them, the methods. So if you have an image, you could clip it or you could sample it. And this syntax is the same whether you're in Python or JavaScript. They're almost identical. And so the real difference is between Python and JavaScript is in the small amount of client code that you might be writing to declare a variable or a function. And so when you're learning Earth Engine, a lot of what you're actually learning is this Earth Engine script, which is the same for both clients. And so this is just sort of an example of it in code. On the left side, we have the JavaScript, and on the right, the Python. And if you look through them, you can see that 95% is the same. It's the Earth Engine script. And there's just minor differences in how we declare a variable with JavaScript using the var, or how we declare a function using function versus Python. And so we write this code using client libraries. And Kelly, do you want to talk about client libraries and how they work?
Yeah, sure. Yeah, so really what a client library is a particular implementation of how a user interacts with these APIs, right? So right now we have JavaScript and the Python client libraries, and on the back end, what they're really doing is calling a REST API, and that REST API is the same between the JavaScript and Python. And really what's going on the back end is those client libraries are, you code up what you want to do in Earth Engine. Those client libraries translate it into instructions that get passed to the REST API, and then those REST API passes it to the Earth Engine servers that do the work, right? And there's also that translation back that happens, right? So recently, I'll talk about this a little later, but Steve talked about the data extraction or data converter APIs and passing them into Python data structures. So that happens through the client libraries. You can do the same. Well, I don't know if there's equivalent data structures in JavaScript, but more or less you can pass that information from Earth Engine into those data structures in JavaScript, and that's really what the client libraries are doing. So this is just to say that between the two, you're really calling the same Earth Engine. Okay, and then another big differentiator between the two is also development environment, right? So a lot of developers have their favorite tools that they like to work with, whether that's a integrated development environment, whether that's the command line, whether that's a Jupyter notebook. So there's a lot of tooling that you can actually do some development in, and that's really what the development environment is. And so the different client libraries, JavaScript or Python, have these different developer environments and different developer experiences that you would have as a user to interact with Earth Engine. Right, so on the top here, we have examples of different developer environments where Code Editor is really our main one that everybody knows and loves, hopefully loves, to interact with Earth Engine, right? You also have a command line. So we have a command line tooling, or if you're really into that and like to sit in a coffee shop and impress everybody, you can do all the stuff in the command line. There's web apps and also notebooks, right? So these are four typical ways that you interact with Earth Engine in these different developer environments. And all this to say is, but starting on the left here is really JavaScript, and then there's some blend here in the middle, and then on the far right there is Python. So it's really what you're most comfortable with. And again, what it's doing on the back end is you have these client libraries that are then creating the expressions that Earth Engine evaluates. I skipped ahead. So really, again, so if you want to make a clear line on where JavaScript sits and where Python sits in the developer environments when you're working with Earth Engine is JavaScript, Code Editor supports JavaScript, right? So when you go into that little middle pane there, and we'll show an example of this, you're using some flavor of JavaScript, but it's really the Earth Engine love language. And then on the right there, when you're interacting in Colab notebooks, that's one of our suggested ways to interact with Earth Engine is using Colab. You create your code in Python, like your typical Jupyter notebook environment. All right, so we're gonna start diving into comparisons, and then we're gonna shuffle back and forth, right? We joked around we needed to do a rap battle, but I'm not that creative, so it would have been really bad. Okay, so first off, so we're going to go through a couple like highlights on how a developer works with Earth Engine, some of the tooling that you use, and compare and contrast between the different client libraries, and talk about the pros and cons and why you may choose, if you're interested in a particular facet of the developer experience, why you may choose working in Python or JavaScript. All right, so the first thing is, we work with Earth observations. We love looking at Earth imagery. That's what got me into the field. Saw my first satellite image and I was like geeking out. So you want to display a map, right? And so in the Python side, the main supported library that we have is GEMap. This is a third-party library. We are working with the developer of GEMap, Dr. Qixing Wu, to help support some of those core functionality. And that's really what we're suggesting you use in the Python experience, right? And so on the right here, we have an example where you are coding in Python, and then you can have your map and display results, right? This comes with, it uses IPy leaflet. The nice thing about this is you can bring in a lot of extra outside web mapping layers, XYZ services or WMS. And so you can start pairing your results with Earth Engine with other visualizations that your organization may have. There's layer control, multiple maps, you can draw tools or draw polygons and stuff. And now we're really excited about this. It's pre-installed in Colab. So there's no like pip install GEMap, and you can just get going started with it.
And then, of course, we have the code editor, where the map is probably the most prominent piece of it. And the integration here is really tight. I think if you're in the plenary and you heard Steve talk about, there's been sort of 10 years of investment in the code editor, and so it feels very polished. And the map, it feels like a very central component. And it's super easy to work with and inspect it. Drawing tools, there's a lot of parity with what Kel just said about GEMap. And I think maybe one of the differences is the fixed panel. So in Code Editor, the map is on the bottom and it's always there. If you're working with GEMap in Colab or another Jupyter environment, you have the option to have multiple cells or switch the location of it. I don't know if there's much more to say.
I'll just add in the legends part. So with the Python ecosystem and GEMap, it's pretty straightforward to, and Qixing Wu did a great job creating a helper function to create a legend in the map. And then in the code editor, it's sometimes you could do it, but it's you got to code.
Yeah.
He's the one that knows how to do it. Okay, so the next thing you want to do is data exploration, right? You want to understand what's going on with the data. You want to see what the data has in terms of properties, information. You want to change how you're viewing the data and things like that, right? So in the Python or Colab experience, really when you're looking at data, if you want to print an Earth Engine object, you're outputting that information to the Python or notebook standard output. So this is a screen grab of the demo that we'll walk through. And essentially, if you just say print this or give me that climate temperature collection, it will. There's some nice third-party libraries that will then print it in a nice format, right? The other thing is you can use .getinfo. .getinfo is the way to tell Earth Engine, give me some result, right? And so when that happens in the Python world, that is a synchronous call. So when you say get info, you have to sit there and wait for the result to come back. And that can be sometimes minutes for that result. So with that caveat, just understand when you're calling get info and telling Earth Engine to give you a result in Python world like that, it can take some time. The other thing to highlight, we talked about this with the maps, but if you want to inspect your data, right, so if you go into the code editor, there's the inspector tool, and you will click on a point, it will give you the pixels. You can also do that with GEMap. So this little GIF here showing if you go to the tool and just zoom in on a location, then you click on a point, it should, and again, this is a synchronous call, right? So it may take some time, but it'll give you those results at that pixel that you clicked. The other thing is raster stretching options. In the code editor, you can go in and click on that little gear icon, change what your visualization is for the map, and this animation here is showing how you may do that with GE map. So there's a lot of that functionality that's there to where if you want to do some data exploration on the map, and even with the Earth Engine results and the Earth Engine objects, you have those capabilities in the Python world.
Yeah, so Code Editor is really similar to what you just saw with GE map. A lot of the same functionality where we can display a map, we can click through layers, we can add stretches to them, we can inspect the layers, and the output is formatted, well, EE-Repr has formatted the output to look almost exactly like it does in the code editor. So the parity there is very close. In the code editor, when you're printing something, it's also calling getInfo because we need to get some information from the server to your client. And the way to do that is with getInfo. But the code editor hides it from you, and it's also able to do it synchronously. So that's maybe one point for the code editor, that if you're printing multiple things, some quick running process might give you that result, and meanwhile you're still waiting for a longer result to come up, but it won't lock, it won't block that quick running result from printing.
Yeah. So the other thing, building on top of data exploration, another common thing that you want to do is visualize as a chart or make a plot of your data. And so there's a lot of tooling in the Python world to make charts, and this builds on top of the standard matplotlib and things like that, right? So in GE map, there's a lot of functionality to create quick plots and visualizations if you're clicking on the map, and that uses a tool or a library called BQplots. And so that somewhat has limited functionality. You make very common charts like a time series. The really nice thing with the Python and Colab side of things is really you can use any charting library you want, right? That includes matplotlib, Seaborn, Bokeh, Plotly, the list goes on, right? There's, I don't know how many different plotting libraries in Python. And so you display those cell outputs, in a notebook environment, you just say, here's the chart, and then that output gets put into the cell output. And then you can also manipulate the underlying data. I think the really interesting thing with the Python and Colab side is you tell Earth Engine to give you those results, and you just have those results locally on your environment, right? And so if you need to update your plot, or if you need to change something like coloring, it's very quick to do that because the data is local. You don't have to submit another request to Earth Engine. And so it's really nice to be able to change things without having to rerun, and then create publication quality charts using the Python libraries.
So you can chart with the code editor as well. And it's really convenient for prototyping. So there's a series of built-in functions for really common types of charts that you would want to plot using image collections or feature collections. And it's using Google Charts, which has some limited capabilities in terms of like scientific statistical charting. But for the most common plots, it's very convenient to turn image collections and feature collections into a chart visualization. That's the only option you get is Google Charts. And it's a little bit harder to do reproducible charting. So it really feels like the benefit here is convenience and quick prototyping.
All right, the next hot topic on the list is machine learning, or AI. So with the Python and Colab environment, who here's been here before, or like played around with the Earth Engine classifiers? Okay, so a few people, right? So in the Python world, since you are using the Earth Engine client library, you have full access to all of those Earth Engine classifiers like Smile Random Forest or the SVM. The nice thing, again, about the Colab experience is you have these standard Python machine learning libraries like scikit-learn, TensorFlow, PyTorch, that you can integrate those results from Earth Engine into and start working with. So there's a lot of common workflows where you're preparing data, you are training your model, you're deploying your model, and you would do that all in a Python environment with Colab or something. And so you start with Earth Engine to get the data out, maybe using some of those data extraction APIs that were recently announced, and then you end the analysis with Earth Engine where you're running your models at scale and displaying those outputs there. So you have a lot of flexibility, but with that flexibility comes a lot of sharp bits where you can get yourself tripped up or maybe do something or deploy a model and maybe run up some costs or something like that. So there's a lot of sharp edges that you need to be aware of when working with a lot of these AI models for deploying and stuff.
And Code Editor's got round edges. So you can use the EE classifiers, and there's quite a few standard options. Max int, decision trees, SVM, min distance, cart, random forest, and we have built-in objects for doing confusion matrices and looking at accuracies. So again, the convenience factor is very high for more complex types of classifiers. It's maybe not the best route, but you can run your hosted models that have been trained and hosted on Vertex AI. You can scale up by running them in Earth Engine on the data catalog.
Okay. The other thing as part of a developer experience is you create a script, you create a workflow, and you want to share it with your colleagues, or you want to share it as part of a publication to the greater community. And so in the Colab experience, Colab is integrated with Google Drive. So when you're sharing the data or when you're sharing your workflows, you really add users, you add groups, organizations, much like you would with Google Docs or Google Slides, anything like that, right? So there's that little share button on the top right. And then when you click on that, you can go in and share it with all of your friends and collaborate on the notebook together. The other thing is you can save your notebooks to GitHub. So there's integrations on Colab with GitHub where you can save it to a repository or save it as a gist. And what that does is create a link from GitHub, and you can do your general code management in GitHub, but always open that back into Colab. If you're using scripts or workflows that someone else has developed, and it's installed in a Python package, you can also install those third-party libraries that do, we have an example is GE tools that some people in our community have developed, and so you can install that and start integrating in the Python experience as well.
So in the code editor, we have the scripts panel, and it allows you to save scripts and explore them and share them right within the code editor. They are Git-backed, and they exist on Google's infrastructure. You can access them with traditional local Git, but it's kind of a complicated process. And so it's sort of siloed here. Your scripts are a little bit siloed within Earth Engine. One of the best features, I think, of the code editor is the ability to get a snapshot of the script that you're working on, the get link button. And this has been an excellent tool to proliferate example code all over the internet, for better or worse, maybe. But it is a really great feature to get a quick snapshot of what you're working on, share it with somebody for getting help, or show people what you're working on. We also have this concept of imports. In the code editor, there's a require function which will allow you to import a saved script into the script you're working on. So if you have a lot of helper functions, some kind of analysis that you do really often, you can save those functions in a script and then reuse them in other scripts. And so people have used these a little bit like shared libraries, but since there isn't version control and there isn't a package managing system, it's a little bit rough to use it for that purpose, but that does exist.
Okay. One of the other things, again, that you want to do in an Earth Engine developer experience is manage your data. If you're exporting data or ingesting data from your organization, and also share that data, right? So in the Python developer environment, there really is no way to point and click and ingest the data through a UI. What you have to do is use the Earth Engine command line interface or use the underlying ee.data commands to manage those ingestions. So, but you certainly can upload, manage, and update the assets. There's a lot of flexibility, but there's also a lot of complexity that comes with that. The nice thing about working in that environment is you can programmatically create and manage tasks or manage uploads. And so if you need to do large bulk uploads of, say, thousands of images or export thousands of images, this is a great way to automate that workflow because you're not having to go in and point and click. And so that helps automate this stuff. There's no built-in task manager into the developer environment, so you have to go to another UI or another tab to go. We have a dedicated web page for tasks. This is that code.earthengine.google.com/tasks. So if you are interested to see your little task pane, see what's running, cancel things through a UI experience, you'll have to go to a new tab to do that. But again, the real highlight here is the ability to script and bulk manage your assets and copy things or upload things or export things.
Code Editor's got nice UIs for data management. Again, there's this assets. There's a panel that will store or display the assets that you have. You can organize them by folders, projects. They're very easy to see. You can get to the GCP, the cloud platform project right from these assets, so it's easy to manage. Export tasks, there's a panel for that. So you never have to leave the code editor for these things, which is really convenient. You can also upload data here, but it's through a UI. So you're button clicking to find the file on your computer, upload it, specify some information, some metadata, and then click the import button and wait for it. So, it does make it convenient if you've got just a few files. If you've got a lot of files, Python's probably the way to go there.
All right, so that's more or less the main workflows that we identified as a user would go through or are interested in. So we'll have a section to talk about a lot of this. So we're interested to hear some of your experiences. But now we want to dive into some edge cases that are more unique and also more advanced from a user perspective. So in the Python side, again, highlighting what Steve announced was the data extraction and data converter APIs. Those are exclusively for the Python API. What that really does is just allow you to get the data into those Python data structures. The other thing that you can do in the Python side that's more advanced is you can create these packages that call Earth Engine and provide those extended functionality, right? So also, which was announced, the XEE, or calling Earth Engine or interacting with Earth Engine through Xarray objects. That is a package that you can install in the Python environment, and that provides extended functionality. So it allows you to share your code, share your reproducible and extendable code for others to then work with. In Python world, there's a lot of tooling around web apps. So there's this example here on the right is showing a Streamlit app that was developed by Dr. Qiusheng Wu. And so you can take that workflow and then deploy to like a Flask or Django application. It's fairly straightforward. I don't want to say it's easy, but it's straightforward. And then so the also thing with the Python side is it's great for creating production or deploying. It's great for creating production systems and deploying with different APIs as well. So in the Google Cloud world, we have hundreds of services that are all built on client libraries, and they support a lot of languages, but Python across the board is supported. And so in the Python world, you can start integrating with a lot of the other cloud services as well fairly easily. And I just want to note here too, that's not exclusive to Python. It's just there's a lot of documentation and examples using Python. And so you can do the same things with JavaScript. But I would say that a lot of the data science functionality, you're going to be better served staying in the Python world versus working in JavaScript on the cloud side.
And with the code editor, we've got a couple things that are not available for the Python API. So we have the feature view, which is a vector data set, format, and it allows like really fast rendering of feature collections. So you can see the example there, how much faster feature view is. And then we also have Earth Engine apps, which allow you to script a UI, display data, maybe do some kind of analysis, and then publish this app, which is hosted by Earth Engine on Google servers. And you can share this app's URL with anybody. They don't have to have an Earth Engine account, and they can explore your data and run maybe a short analysis. Some demos.
Yeah, okay. We're going to switch over to the demos, and I think I'm going to drop this. Is this working? Okay, can everyone hear me or no? Okay, cool. Okay, so the first thing that we're going to do is walk through a Colab demo. So I'm just going to restart this. So the links here, so the slides will be put on the website and made available. We also have a tiny URL, which we'll go back to the first slide. So if you want to grab that. So these links are available to you, and you can go to them and play around. Again, we're not going to do hands-on here because really I think we wanted you to just watch and us walk through some of the pros and cons between here, because this example, and I'll talk about it, this example is really meant to just kind of like highlight some of the different functionality and also challenges that occur. So the first thing here, in a notebook environment, I really like the notebook environment just because you can tell a story with it, right? You can add in, not to say you can't do that in a code editor, but you just have that story, have notes, share things. One of the main things I would say that's somewhat of a hindrance in the notebook environment is setup. Previously, before we integrated GEmap into the Colab runtimes, you had to install GEmap. If you want to install Python libraries and that aren't supported or aren't pre-installed on Colab, you have to install those. In this particular example, if there's a Earth Engine release that you want, you have to upgrade to that particular Earth Engine release to make sure you get all the cool functionality that just got released that Steve announced.
Just 1 second on that point. Hey, could you talk about the release cycle to Colab?
Yeah. So the Colab runtimes get updated with new versions of the Earth Engine Python client libraries about every 2 weeks. So at most, you'll ever be 2 weeks out of date on a Colab runtime. But there were some features that went into the release, I think, last Wednesday, and some of the Colab runtimes haven't been updated yet. So that's why you have to manually upgrade here.
Perfect. Thanks, Nate. Yeah, and it was a great example, right? Like, we release a lot of cool features, and we wanted to have those and show them to you for today, and to make sure that the virtual machine that you're working with has that version, we have to run this pre-install. You also import packages, and so a lot of the tooling that you may have with Google authentication or Google Cloud, those are available. But you can see here that we're importing in, your standard Python libraries like matplotlib to use. Another main challenge here, I guess I'm already authenticated. Sorry about that. I'm gonna restart this. One of the other main challenges that happen in the Colab environment is authentication, right? So you are running code, and you need to say that you are authorizing that this code is running for your account. And so there's a lot of security. We take security very serious here at Google, and we want to make sure that when you're running things, you are aware of that, and you have, and that you know that this notebook is accessing your credentials. So here in this auth flow, you can see that I have to, click I'm allowing this, and then sign in with my account, and then acknowledge that Colab can then access my Google Drive and other things, right? But what's also fun too, so all that aside, the fun thing is you can develop these nice user input cells, right? So you can start developing a little bit of a UI to where a user might interact with things. So I'm going to put here my cloud project that I use with, if I could spell right, that I use with Earth Engine, and then do that authentication or initialization process, right? So here I'm pulling in the authentication credentials that I just signed in with, and then initializing Earth Engine with those credentials, saying, hey, Earth Engine, I'm the one that's asking to do something, and then route it through my cloud project. This here is highlighting GE map. So what we're doing here is creating a GE map object. So again, you don't have that map directly on your web page, and so you have to create the object and then create the map. So here I'm highlighting a nice feature in Colab, which is a scratch cell. And so you can create this scratch cell and then have your map here on the right. So this is a pinned map, and then as I'm adding data and working through things, my results will then be added to that map instead of having to scroll up and down or have multiple maps or anything like that, right? So the example workflow that Justin and I kind of landed on here was working with climate data. That's on the forefront. I hear a lot on news. I like to see the world is burning, but in climate data is a lot of data, but it's global, it's interesting. So here we're going to pull in some recently released CMIP6 climate projections. We're going to filter down to a particular model run and then a particular scenario. So when you're looking at this code here that I just highlighted should look very familiar that if you've interacted with Earth Engine, right? It's like Justin was saying, it's more or less the same interactions with the objects, the nouns, and then the methods, like what you're actually doing with the objects. So here it's highlighting that if you just display the collection, you can see that this is outputting a collection in a nice interactive format, so you can inspect different bands, different properties, play around with stuff here. Just a caveat, this is limited. This does call getInfo on the back end, and it is limited to that 5,000 element. So if there's a large collection, say Landsat with millions of images, don't try and print that because it will say, "Merp, don't want to do that." Okay, so this example that we're showing here is we're gonna get present temperature for this year, just an average temperature, and then we are going to add it to the map. So here I'm defining my map visualization, and then this is the function to add to the map. And so now you see here on the right, everything's adding in. And then to create a color bar, this is the code, right? So I mentioned there was some nice functionality to add in a color bar. And so I can add that. And then what we're doing here is adding in, again, future temperature. So this is end of century temperature, right? And then adding that. Oh, sorry, you don't see my full thing. So you can see the color bar there at the end. And now I'm adding in the future temperature, and you can toggle and compare them in the map inspector, right? The other thing that we want to do is, this is just highlighting some computation. We want to compare today's temperature versus end of century and see what's changing. So again, this is doing that computation, adding it to the layer, and then adding a new legend, right? This isn't just image. This isn't just image files. We can also do vector data or feature collections, and so this is highlighting, adding in the FAO admin level 1 layers, right? So for a data exploration example, what we wanted to highlight is just some example of creating statistics over all of the United States, and then doing some time series analysis, right? So this is quite common. You want to just see like what the data is for all these regions, and go into a time series analysis. So here I'm loading in these packages that you would use for any Python analysis. I'm doing some filtering to get the continental United States, so no Alaska, no Hawaii. Sorry about that. We're omitting you for this analysis. And this particular example is calculating the temperature change. So today's temperature versus future temperature for all of the states. So we're doing a reduction, reduced regions over all the states. And that ran pretty quickly because I haven't requested anything yet. It's just the client library has said, here's my computation that I want to run. So here's a nice new feature, a nice sparkle new feature. So this is one of the data extraction APIs and data converter APIs. So here we're calling EE data compute features, and we're specifying that the file format is a GeoPandas geodata frame. Hopefully this will run fairly quickly, but essentially what this is doing on the back end is, maybe Nate can tell more about what's happening on the back end, but essentially what's going on is it's saying, okay, here's all the features that I want, give me those results. If there's a large amount of features, it will go through all those pages, over 5,000 different features, and it's getting the results and then converting those results for you into that GeoPandas data structure. So you don't have to do any of that. It should be, as you see, it's fairly straightforward code to just get a GeoPandas data frame. And then you can start working with it like you would in any GeoPandas workflows, right? So this will take a little bit. I was hoping it would cache, but I blame everybody doing the machine learning session. They're taking all the Earth Engine compute. Just kidding. Are there any questions while we wait on stuff, what we've covered or what I've just gone through? Okay, and for questions, we're recording, so if you can just wait for a mic. Thank you.
Hi everyone. I actually have a question on this very cell that is running. How this is different from GDF equal GDP geodata frame parentheses, and then I just do a get info on my collection, because I assume that you updated it and then like extending the limits and everything.
Right. So the get info, what you're actually going to get as a response, and again, Nate, correct me if I'm wrong here, but what you're going to get as a response is a JSON object, and that will be a GeoJSON equivalent. And then you have to take that GeoJSON and then convert that into a GeoPandas. It eliminates some code here, so it's you could replicate what you're doing, what this is doing, but it eliminates some repeatable code that you would do and just makes it a little bit cleaner from a user experience.
I have something to add. With this particular compute features function, what it's actually doing behind the scenes, if you specify GeoPandas geodata or pandas data frame, is it's making a bunch of fetches in the background. So it could be hundreds of fetches, and by default it's increments of 1,000 features at a time, but it keeps all those in memory and then stitches them together for a GeoPandas geodata frame, which is different than if you don't use this file format and just use something like GeoJSON.
Okay, thank you very much.
Great question. Thank you. Okay, so moving along, I know we're getting short on time here. This is GeoPandas. The highlight here is you could do what you would normally do with pandas, like create a nice map. I'm just going to click through here. So this is a GeoPandas plot, and then also do some nice visualizations here to where this is just change in temperature for all the United States, average change in temperature for all the states. You can also, like I said, this is doing some local, so now we have the data frame locally, and so then we can start extracting out information from the local data structure. So this is finding the min-mean structure, and then we have this function here that's going to create a time series for the minimum. Well, it takes a state, gives you a time series result, and again, this is highlighting some of those new features with compute features. We're going to get a collection, and we want that collection properties as a pandas data frame. And so calling that for the minimum state, which I believe was Rhode Island. Yeah, Rhode Island. And then the maximum state was Montana. So if you like hot weather, move to Montana. If you like cold weather, stay in Rhode Island. And then you can start doing like pandas work by concatenating the data and then doing some time series, right? So that was a quick run through of the Colab, and so I want to shift over to I'm going to reset this for you. Oh, sorry, womp womp. It's always good to save your work. I meant to clear the output. Sorry about that. Shift over to Justin.
Thanks, Cal. All right. So the notebook is great for storytelling, as Cal said. In the code editor, it's just one monolithic, it's hanging up here, script. One single cell of script, no outputs in between, no text. And so you can't run each cell individually. There's the single run button, which runs the entire script. All requests are made, and you can see they are running asynchronously and printing as they go. So some have already completed. We've printed the image collection, and we can see that it looks very similar to what Kel showed. We get all the metadata about our image data. It has a lot of the similar display features that were shown in GEE map. We can display the map tiles. We can turn the layers on and off. We can change their transparency. We can add legends, but it's not nearly as convenient as GE Maps easy function. In here, I've got this add legend function, which is many lines of code because we have to create this whole UI, all of these HTML components to build these legends. So this might be something that you include in a helper module that you import, sort of a legend builder. What else? We can replicate some of the charting that we showed, but it's, again, not nearly as easy to do. It takes a bit more coding to generate this. And as it appears in the code editor, it's not that useful. You can, really stressing it out here, you can pop out these charts and get a full screen view of it, which then makes this one a little bit more interpretable. And right now it's trying to generate the equivalent of the GeoPanda map of the United States, something like a reproducible figure that you could include in a paper. It's, oh boy, crash, full crash. And you can sort of do that, but you can't add a legend to it. You can't add Latin long, for instance. So it doesn't quite work as well for publication quality. But the convenience factor of having all of this integrated, is one nice thing about the code editor. Let's see. Try going to the link again if you want to. What? Just go to the,
Yeah, refresh that. Should work.
well, in any case, we can, as you can see, we can reproduce both of these analyses in GEMAP and the code editor. We're now going to get maybe some cache benefit. Sure. Get a microphone over there.
So the code editor allows you to export it as a CSV or something like that. So you could then take it into a different software to produce kind of your, tailored publish quality chart. And so do you have a sense of, even those that use Python, because I know scientists are very picky people, and so do they tend to take it into Excel or something and make their own chart anyway, so that maybe that's not as important of an issue?
Yeah, I think likely, or they're, exporting, maybe not from the chart, but you could export your feature collection, basically your table, as a CSV. I think that's what I've seen more often. They
Right.
export it to Drive, and then
Yeah,
they've
that's
got a
what I
copy of it. Yeah. But for quick prototyping and viewing a chart, I think it's great right in the code editor. Should we move on to?
Yeah, I think so.
Yeah.
So, we wanted to leave you with a couple slides as a summary to talk about the pros and cons of the different developer environments and different APIs. I think the big takeaway here for the Python Colab is it's great for automation. It's great for ML workflows. You have a lot of flexibility in what you can do with it. But with that flexibility comes a lot of those sharp edges that I was talking about, right? The authentication, the setup that you need to do. We don't have as rich documentation for Python, but we are working on it. And so there should be feature parity in our documentation between JavaScript and Python. And then there's not as much convenience in terms of embedded functionality with the assets, with the documentation, with the task management that you have in the code editor.
Yeah, I think the code editor, it's all about convenience. There's no setup like there was with Python. It's so easy to get in and just start coding and displaying data. And then being able to use Earth Engine apps, I think, is another big thing about the code editor that's really nice. The script that you've developed, you can turn it right into an app and share it with anybody that doesn't have a Google account or the programming skills. Some of the cons is that it's inflexible. It's in a sandbox. The advanced ML features are limited. No package management system for saved modules, so reusing code from other people is more difficult. And no integration with GitHub, which makes it a little bit challenging to coordinate and collaborate on scripts. Those are the high points.
Yeah, and really, I hope, if you take anything away from here, the experience, the different APIs that you use, Python versus code editor, it really depends on your use case, on what you're trying to do, right? And there's a lot of dimensions in terms of how you may make that choice. And so that's really up to the developer. There's no right or wrong way to interact. Well, there may be some wrong ways to interact with Earth Engine, but between JavaScript or Python, either choice is a great choice, and it's whatever you're most comfortable with, and that can make sure to get your work done, right? So we wanted to shift into real talk, and I think we can maybe go over 5 minutes, if everybody doesn't want to leave here right at time. So, from my experience, I use both, to be very transparent and honest. The main use case I want to talk about is me working on my PhD. So the code editor is so great for getting in. You do not have to set up anything, and you can just go in, say, I want to search for this data set. I want to bring this in. I want to explore what's going on. I want to quickly prototype what's going on, and then have a result, right? So that iteration to get to something is very quick with the code editor, right? And so then once I was happy with what I was working with in the code editor, then I shifted into a Python environment where I took my workflow and scripted it in Python. I made that something that I can automate. And I just did like batch exports, like queuing up thousands of exports, and then I would just let that run for a week and then come back later, right? And so the point is the code editor is really great, and in my opinion, it's really great to just get in there and start working with things, explore things, create a lot of fun applications and visualizations. And then when you want to get into the production or automating things, then Python is really where I like to sit and work in, so that way I can start scaling out my workflows and stuff. I also support a lot of cloud customers, and so again, integrations with those cloud pieces, I really like working with Python for that. So.
Yeah, similarly, Code Editor is my first place to go to if I'm prototyping something, just the convenience of it. I also use Python, and I use it mostly when I have to automate some kind of task, ingestions or exports, making animations from thumbnail images, and also giving demonstrations or lectures or talks. It's really nice to use a Colab notebook to more easily walk through and narrate and run each cell. I've gotten into problems sometimes where I'm in the code editor where I feel most comfortable, and I get really far along in my process, and then I realize that this is working really well and I need to do a bunch of exports now, and then end up having to convert my JavaScript code to Python to do the exports. And so I have to keep in mind sometimes that when things start to look like they're on the right track, and I might think that I'm going to do a lot of exports, to switch over to Python a little bit sooner. So thank you. And if anybody else has experience or questions that they'd like to share, you can take them. Let's get the mics.
Hi, thank you so much for that. What I do want to share with you is that when I work with medical communities, what I always say is the stethoscope doesn't do the diagnosing. So it's the person behind the tool that has the expertise. So it doesn't matter what you're using. It's you. You're the unique part. What I use it for is I travel the world talking about the built infrastructure and how it impacts social inequity. So you guys didn't give it a plug, but Colab Pro is just like dynamite for that, because you guys know the size of these building imprint data sets. And you could, I personally, in my little, one human office, could not run this stuff locally without a tool like that. So I do a lot of my querying and peeking around and figuring stuff out in the code editor, and then I'm building it out like you are, because I have to present the stuff into a nice notebook, and you can make beautiful stories inside that with Markdown and bringing in images and music. And people always ask me when I'm done, like, how did you do that? And when I tell them that was a Colab notebook, they really look at me like I'm crazy. And I might be. But thank you.
Good plug for Colab. Also, they now support enterprise use, so cloud
It's like
customers.
$5 a month or something ridiculously cheap. It really is nothing.
Yeah. Yeah. I don't know if that's worth a note at all. Do you know anything about Colab for enterprise?
Yeah, so what you've worked with Colab Pro is really our consumer application. So if you work in an enterprise, like big federal organization, big company, and you want to then leverage cloud and a lot of the VMs in there. So there's a Colab Enterprise instance through our Vertex AI service that you can actually pick what VM you want, what GPU you want, and everything like that. And it's the same Colab runtime. You just have full control over what the VM is and the sizing of that. There's a little bit more flexibility on the enterprise, and then on the enterprise too. Like the Colab Pro is really for like individuals, and then Colab Enterprise is for data sharing, working for large organizations and things like that. So there's a lot of different ways that you can have more compute with it.
if you are developing a package or library that's going to be useful to other people, what do you do it in? Do you do it in Python? Do you do it in JavaScript? Do you do it in both?
Great question.
Do you want to
The
start?
ones I've built have been in JavaScript. I think mostly because it was early on, and more people were using JavaScript. But it's difficult, I think.
My experience is, so before I joined Google, I worked with a NASA program and built a library in Python to do, it basically had like, I don't know how many different flood algorithms, right? So it was just like, pick your flood algorithm. We've already coded it for you. And so that was all in Python. And so my experience with it was, I wanted to work in a IDE. I use VS Code. So that has all the tooling that I wanted with integrations with GitHub and the terminal and testing and things like that, that I wanted to use as part of my development for the package. But I used the local Jupyter environment. So it was using GE map and the Python code editor. But I was importing in those packages and working through the same thing to make sure what I was developing and my development branch and everything was doing what I was expecting, and so I can expect the map and things like that. So it was a little bit outside of the notebook environment, but I was still using GE map and doing your typical workflows that a user would do, but I was testing that to see the results from my package. What I was doing was actually giving the right results. Any other questions?
So that's again a question about Python. So you were mentioning that in Colab, the main limitation that you have, I mean, you talked about it a lot, and it makes sense, is sharing the environment. Because when you're doing research or you want to publish or you want to share what you've done with others, it's always extremely interesting to share the environment that you've used to compute everything. I've used other notebook solutions than Colab's, where through GitHub I can share my requirements.txt or my environment.yaml and recreate this environment from scratch. Is it a functionality that will be or you would like to include in Colabs?
We do have functionality for that, but that is Google Cloud. So again, it's not necessarily a individual user application. That's not to say as a user you can't do that. So in Vertex AI, we have Colab Enterprise. We also have a service called Workbench where you can deploy Jupyter Hub instances. And with that, you can create Docker containers, which have all of your Python dependencies. And it just has to have that Vertex runtime. And I can point you to the documentation on how to do that. But you basically pre-install everything and you say, Vertex Workbench, run this Docker container runtime, and it has everything that you need in there.
It's got to be enterprise within the Docker. It's got to be enterprise Colab.
No. The Docker container is just, the Jupyter runtime and your packages, and then you deploy that where you want to deploy that. And to elaborate a little bit more, the Colab Enterprise, you cannot, other than doing like pip install, you cannot change packages in the Colab runtime because Colab is a managed runtime for you. This would be deploying your runtime on a Jupyter environment within Vertex Workbench. Getting my exercise.
So I use both most of the time, but let's say I have a code on Code Editor and I want to export but using Python. Is there a way where we can use something like require? So instead of actually recreating it again on Python, I just use, the export function because it's much faster on Python.
And these are batch tasks, like you set up an export to Drive or cloud storage?
Yes, to cloud storage.
And yeah, it would be the same whether you ran it in Python or JavaScript. So that batch stack, if you hit that with Python or the JavaScript client library, it's hitting the same server. So there won't be any benefit to switching a language for batch tasks.
Okay, but let's say for other like things, not just export. Do you think it would be available eventually, like this functionality?
To be able to like translate, have like scripts automatically translated.
No,
from
so instead of translating, just take the output and then continue using it, but on Python.
You'd have to save it as an asset, probably.
Yeah, you'd have to save it as an asset, and then I think what you're talking about is in computer science called polyglot. So you're having a runtime with different languages and their shared memory and passing the data structures. We don't support anything like that.
There's the option to serialize and deserialize. So in JavaScript, you can call serialize on your expression and get a saved chunk of JSON, essentially, which you can then pipe into Python and deserialize. You're going to be sort of unhappy with that. You lose information about the types, but it does give you a little bit of wiggle room to go between one language to the other, because you're just passing something that the server understands in JavaScript to something that the server understands in Python. Worth checking out.
We're a little over, so yeah. Thank you all for joining the session. I appreciate people staying and asking questions, and I hope you took away where you want to do your development at. So thank you again.
Thanks all.